All right, guys. This is chapter 9. Samples. Students will be able to gather samples and analyze biases. Your homework is page 236, numbers 1 through 9. All. I'm gonna go through this really quick, just because it's just a lot of vocabulary. So feel free to pause the video to copy down these notes, or rewind it. To get some parts that you didn't miss, just in case I do go a little too fast. All right. All right. I do want questions and reflections for this, so let's make sure that we have that as well. Okay. All right. Moving on. All right. Review. Population is everything and everyone that we want to gather data on. Sometimes it's impossible to do so, right? Like a population, like it's really hard to do a survey on a population because it's just too many people. A sample is a part of the population that can represent is a part of the population that represents the population. So it's a smaller bit from that. Sample survey, asking a group of people questions in hopes of learning something about the whole population. So, we're just asking a group of people a question that will yield some information about the whole population. Sampling bias, the act of over or under emphasizing some characteristics of a population. It must be avoided at all costs, and conclusions drawn from the sample biases are inherently flawed. So sometimes when we do a sample, there are things that we do during a sample that creates a natural bias, whether it's, and we're going to talk about all those biases later on this week in a video, but there is a thing called a sample bias. How you get the people to answer your survey or whatever, that can create a bias. One way to avoid a sample bias is this process called randomizing, okay? Randomizing protects us from the influences of all the features of our population by making sure that on average the sample looks like the rest of the population. That's important. The idea that the sample, whatever sample you pick, represents your whole population, not just a specific one. Whatever you're curious about, whether it's like the whole United States, where you have to sample like everybody that kind of just fits in every category of people in the US, or let's say you're doing something a little bit more niche, like the population of Vietnamese people. Okay, within the Vietnamese people, you gotta make sure that all the different types of Vietnamese people are represented. And one way of doing that is by randomizing. So here's an example to determine whether a sample is representative of your population or not. We did 2 different samples of 8,000 apiece from 3.5 million people. We want to explain, are these samples representative of the population? Explain. Well, if you look, we're doing it twice. So this is the first time we're doing it. This is the second time we're doing it, right? So we're sampling twice. If you notice, within the 2 samples that we do, all of these numbers are more or less similar, right? Because they're similar, that means that this is representative of the whole. This is representative of the population because these numbers are similar. If, let's say, hypothetically, the mean number of children was like 3 and like the wealth bracket, I don't know, just calling it a 7. If it was like that, in that case, where now these numbers aren't really matching up, that means one of the 2 is going to be off. You're either overrepresenting, the mean of children, or you're overrepresenting or underrepresenting the wealth gap, or the wealth bracket, I mean. So because those 2 numbers don't match up, then one of these samples are going to be misrepresented. Okay, they have to be the same in order for you to get a correct representation. They have to be the same. If they're different, then you're sampling something wrong. Okay. How large of a sample? The sample doesn't really matter. Like, when we're talking about how large a sample is, the most important thing isn't the population. Okay. People always think that, it's the population, that if I have 1 million people, I gotta do 10% of that. No, that's not the case. Right? If you do 1 million, there's 1 million people there, a sample of 100 will do. Let's say that there's 5,000 people. A sample of 5,000 people could be 100 as well, 100 as well. the thing that you have to really be careful for is that your whatever 100 people or your sample has to be representative of the population. You can't leave a group out, right? As long as you have every group included in your population, you're fine. Okay. So sometimes like the sample size, like how big it is matters, because if your sample size is too small, if I'm doing a survey on kids at Bolsa and I do like a sample size of 5, that might be a little too small. Like let's say there's 3,000 kids at Bolsa. If I do a sample size of 5, it might be too small because I'm not representing all the different kids, like all the different athletes, all the different kids are in different clubs, all and all that stuff, right? Like it cannot be representative by 5 kids. Maybe 100 kids would be a better representation of that, and so on. How big the sample size? Once again, you have to make sure it's big enough in order for you to accurately represent your population. Okay. A census is a special sample that kind of tries to include everybody, the sample of the entire population. Okay, there's problems with the census. We kind of talked about it before. A census is really expensive. Getting surveys or the time that it takes to get everybody is really, really high, right? It costs money, not even just money monetary, but time, right? To go out and do all that. It's hard to locate everyone, right? Like what if we're doing a survey at Bolsa and we want to do a census? What if a kid's absent that day? Right? If a kid's absent that day, then what are we going to do? Or what if we're doing a census of the US and we're mailing it out by people's addresses? You know, what if that person moved? Then there's no way to really track them unless their other thing is on file, right? Their records are on file. So it gets a little tricky with the census. We don't need a census. We do what's called a population parameter. It's a number that's used to model the population, right? The example that I have here is 21.7% of teens never really or rarely wear a seatbelt. Did I go out there and ask and do a census of every single teen? Probably not, right? Or whether they wore a seatbelt? Probably not. So what does 21.7 represent? Well, 21.7 is probably taken from a sample, right? Like maybe I did 100 teens and 21.7% of teens say that they rarely or never wear a seatbelt, right? But we take that 21.7 from the sample, right? 21.7 is a number that we found from a sample, and we apply it to the population. That's a population parameter, right? Like the parameter of the population fits within this 21.7. That whatever we got for the sample can be applied to the population if we sampled correctly. We use data summaries to estimate the population parameters. Any summary found is called a statistic, or we call a sample statistic. They mean the same thing. We already kind of know 2 of them. We already know 2 types of parameters, the mean and the standard deviation, right? Like those tell you something about the sample. Like the mean of the sample is whatever. We can apply that to the population as a whole. We use samples because we can't work with the entire population, right? And I've really stressed a lot about representative. As long as your sample is representative of your population, you're fine. So here's some examples. Why is each of the following not correct? It is always better to take a census than to draw an exam. It's not correct because censuses are what? Expensive, right? Time consuming. And people move, right? B, stopping students on their way out is a good way to sample if they know, want to know. This one's a little tricky. Part B is a little tricky. I would say, yeah, like that's not correct. And that's not correct. That's not correct because I would say that's not correct because I'm not gonna write it because it's gonna be a lot to write. It's not correct because kids that are coming out the cafeteria obviously kind of enjoy the food if they're coming from the cafeteria. That's going to give you biased responses. right? And what if kids don't eat food in the cafeteria, right? Like, what if they're, in the lunch lines outside? They're not in the cafeteria. How are you representing those kids then too, right? So that one's a little tricky. And we're gonna talk about what that means. Like, that's a special type of bias right there. We drew a sample of 100 from 3,000, and then we need. So essentially, we're getting 100 people from 3,000, or we're getting 1,000 people from 30,000. That's incorrect. That's incorrect because remember, the population doesn't matter. Instead of 1,000, we could have probably done 100 or 150, right? You don't need to set yourself up some sort of proportion. It just needs to be representative. It doesn't really matter how big your sample size is, as long as you're representing everybody correctly. Part D, a poll taken at statistics website. So part D is incorrect because you're at a statistics support website asking kids whether they like stats. Well, it's a support website. Kids that like stats will typically tend to go to that website, if that makes sense. Right? Like, if you don't like stats, you're not going to try to learn more about stats. Right? You're not going to put in that extra effort. So to ask kids whether they like stats from a stats website, that is a bias. The true percentage, well, true percentage is nothing. We don't do true percentage. We don't do population statistic, right? We do a parameter. Right? There's like, I'm not going to say there's no such thing as a population statistic, because what that means in part E is that you're asking everybody, and this is the number that goes with everybody. Well, remember, we're talking about making a census, and there's issues with a census. So we don't want to really focus on population statistic, because that's dumb. We want to focus on what is called the parameter, right? Going from a sample, getting a number from the sample, and applying that to the population. Okay, moving on. So some ways that we find a sample. The first one is called the simple random sample, SRS. It's the idea that there is a way that we can select people equally. Okay, let's say that there are 100 people in a math class in college, and we want to pick a sample of 5 from them, right? I'm not just going to be like, oh, you. I'm not going to pick 5 people at random like that. What I'm going to do instead is I'm going to assign every kid, all 100 kids, 2-digit numbers, 01, 02, 23, 99, 00, and so on and so forth. What I'm going to do is I'm going to use a random number generator. This is important, a random number generator. And that's going to spit out some numbers, and some of the numbers could be like 0, 4, 3, 3, 4, 1, 5, 1. And what I'm going to do is, because I'm looking for 5 kids, I'm going to break it up into 5 groups. So 5 through 0, 4, 3, 3, 4, 1, 5, 1, 2, 5. I'm going to ask the kids with 0, 4, the kid with 3, 3, the kid with 4, 1, the kid with 5, 1, the kid with 2, 5. Those 5 kids are going to be my sample, right? That's going to be my sample. That is going to be me randomizing it. Okay, I'm not going to close my eyes and pick names out of the hat. I mean, you could, but for what we're going to do for this class is that we want to focus on a random digits generator. That's going to be really, really, really important. You guys really need to know how to do this process, because there will be probably a project down the road where you guys are going to create your own experiment, and I want this to be included, the random number generator. You got to highlight this, put a bookmark at this procedure, because this will come up later, sooner or later. Okay, I can't stress that enough. If there are repeats, then we can generate more numbers, or if the numbers don't exist, then we just skip and move on. To use SRS, we need a sampling frame. A sampling frame is just a list of names where we're getting these samples from, right? It's just a list of names. Each draw. So the idea is that anytime that we create a sample, we're going to create a different sample. Okay, so if I'm doing it one round, the people that ask in round 1 will not be exactly the same as the people that ask in round 2. You might have some people that are repeats, but as a whole, the 2 samples will be different. Right? Once again, if you do 2 rounds of sampling, You might get a couple people that repeat, but as a whole, the two samples will not be the same. That's called sample variability. An example of sample variability is like this problem that we did here. We did the sample twice, right? Like here. And if you notice, like the numbers, all these numbers are close, but they're not the same. So we're getting two different types of samples there. The next thing that we're going to talk about is this thing called stratified sampling, okay? Sometimes the population is too big or the people are too spread out over a large area, so it's hard to do SRS. So what we're going to do instead is we are going to split them up into similar groups, similar individuals. They have a similar property called strata, right? Each little group is called a strata. Then within each group, we're going to use SRS. Then we compile all the people picked, and that is called a stratified sampling. Okay, so it's the idea that we're splitting them up according to similar qualities. The example that I have is, let's say we have 100 people. Okay, this slide has a lot of misspelling, so no, it doesn't. Yeah, this is supposed to say women. Whatever. Let's say there's a university and we know 40% are men and 60% are women in the university. And I want a sample of 100 people, right? If I just do randomly, if I just do SRS right now, straight up SRS, right? I can get weird statistics like 30% men, 70% women, or 6% men and 40% women. The issue with this is that this is not representative of the population of the university. The university has 60% women. You can't do a sample with just 40% women or 70% women, because then you're underrepresenting women or you're overrepresenting women. You want the correct proportion there. So what we're going to do off of this 100 people is we're going to survey up to 40 people that are men and 60 people up to women. And that's my strata. I'm splitting up versus men versus women. That the property that they share are men versus women. Okay, that's the property that I'm focused on, and I'm doing it such that the number matches up to the proportion of 40-60%. You're trying to find out what freshmen think of the food served on campus. We believe that men and women typically have different opinions, so you originally wanted to do an SRS, but how should you adjust your sampling strategy? Well, before we do an SRS, let's break up men and women. We're going to do two different types of SRS, one for the men, one for the women, and then make sure that we have the correct numbers for the proportion. Okay, so we're doing a strata. We're doing a strata for men. We're doing a strata for women. The next thing that we're going to do is called a cluster. Okay, this has a lot of spelling mistakes. That's supposed to say one. That's could. Okay, splitting the population into representative clusters. So cluster is the idea that you have your whole population. What you're going to do is you're going to take chunks at a time. Like 30 people here, 30 people here, 100 people, whatever. And you're going to sample those clusters individually. Okay? A lot of the debate and probably the confusion right now is what the heck is the difference between a strata and a cluster, right? And we're going to talk about that. But first, let's talk about a cluster. And trying to find out what freshmen think about the food served on campus. You've considered an SRS and a strata sample. Okay, cool. Now you run into a problem. It's simply too difficult and time consuming to track down individuals whose names were chosen for your samples. So let's say you have a list of names. Okay, you have a list of names. And in that list of names, the names that you pull are like John Jones and I don't know, John Jones, Elizabeth Nguyen or something like that. You know, I'm just making up names. Now, how are you going to go out and search for this John, this Elizabeth, or whoever else you're, pulling out? It takes a lot of time to find these individuals like that, right? It's really hard from if you're just picking individuals out like that. So what we're going to do instead is we're going to do a cluster. So you know that all the freshmen at school are in 10 different buildings, in 10 different dorms. What we're going to do is you're going to go and you're going to pick one or two of these dorms at random, and then you're going to try to contact everybody in that dorm, because now everybody's centralized. Instead of going to all 10 and figuring out people individually, because that's going to take forever, you're just going to go to 2 random dorms, and you're going to ask those people in those 2 random dorms. Okay. Now it's important to understand that the dorms are pretty much assigned random, and then that the people that you're contacting are representative of everybody that you want. Right? That's a lot easier. So once again, sometimes it's hard to look for individuals like, hey, John, James, or whatever, right, in your class, or, you know, to survey. So what you're going to do is you're just going to find where they congregate. I wouldn't say congregate. I would find where they are randomized, like a dorm, and go from there. Okay? You're clustering all the freshmen into these groups, and the 2 dorms that you pick are the clusters out of the whole 10 that you want. That's called a cluster. Okay? Now, you guys are thinking, like, okay, kind of get it, kind of don't. So let's go into a little bit more detail. Stratified versus cluster. In stratified and cluster, you're splitting up data. You're splitting up participants, right? You're splitting up whoever you're asking. That's fine. But when you're stratifying people, you're pulling people out, or you're surveying people based off of a property or a variable, whether they're men, they're women, are they an athlete, are they not an athlete. You're assigning them groups to break them up. When you're clustering, you're just pulling one group out at random. They don't necessarily have to share the same property. 100 people, boom, that's the 100 people that's going to represent my whole population. Okay? Everyone will have a mixture of all the properties, but remember, with a cluster, you have to remember that whatever group you're pulling, the cluster that you're surveying is representative of your population. That's really important. Here's a stupid analogy for clusters versus strata that I read up about. Suppose you're judging layered cakes, right? So a layered cake would be like top layer, chocolate, cream, strawberries, I don't know. So every cake has a different layer, right? As you're baking or you're eating it, there's multiple layers to the cake. If you're judging using like a cluster method, what you would do is you would slice the cake vertically, like similar to what we did in class with the pies. Like the normal way, we just slice it straight down, and then we get out, a little triangle piece. And what we are judging on, if you're judging using a cluster, is you're judging how they all taste together, right? You're eating it all combined, right? You're taking one slice from each cake and you're eating it as a whole, that one slice as a whole. But if you were doing a strata, what you would do is instead of cutting down, you would cut across. You would cut horizontally so that you're judging each cake by layers. So first layer is the chocolate layer. Okay, I'm going to eat the chocolate layer, this cake, chocolate layer, this cake, chocolate layer, this cake. Okay, then the next layer is the strawberry layer. Okay, I'm eating the strawberry layer here, 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 here. You're going off of layers instead of all the ingredients put together. That's my best analogy. Maybe not stupid. I'm going to cross off stupid. I'm going to write smart because I feel good about that. Okay, multi-stage sampling is just the idea that you're combining a lot. So let's check out what we have. Having learned the freshmen are housed in different dorms to sample their attitudes about the campus food, you go to the dorms chosen at random, right? Remember, we had 10 dorms. Now we're choosing 2 of them at random. You're still concerned about the possible differences between men and women, but you know that each dorm, alternating floors are men and women, meaning first floor is men, second floor is women, then men, then women, right? Like they alternate. So how would you design a sampling plan that uses this fact to your advantage? Okay, so the first thing that you do is you choose 2 dorms, 1 or 2 dorms at random. By doing that you're clustering the dorms, right? You're using 2 dorms, you're going to cluster 2 dorms. Now within each dorm, you're going to strata, I don't know the verb of it, but you're going to do stratified sampling. So within each dorm, you're going to ask the men individually. Boom, that's a group by itself, and their results are their are the male results, and then you're going to go to the female floors and ask the females, okay, boom, those are the female results. So you're doing both a cluster. Instead of all 10 dorms, you're only doing 2, and then when in each dorm you're separating between male and female. 24. The next thing is called systematic sampling. Systematic's pretty simple. It's just you have a procedure, like, and you stick to it. Like, hey, I'm gonna do every 10th person. But in order to do that, you have to start at a random spot. Okay, you have to start at a random spot. You can't just do systematic every 10 starting from the top. You got to pick one randomly. Probably the best way to pick one randomly is by a number generator. Like, I'm gonna plug in a number and it gets out, I don't know, like 27. So I'm gonna start at the 27th person, and then every 10 from the 27th person, that's gonna be my person that I'm gonna take. Now it could be 27, it can be every 10, it can be every 5, it can be every 3, whatever. All right, it doesn't really matter. There's other systematic samplings that you can do. You can put all the names in a hat. What you can do is you can draw a name. Okay, the first person I draw, that's going to be part of it. The second person I draw, okay, they're not going to be part of it. Then I draw no one. The third person, that's going to be part of it. The fourth person, not part, and so on and so forth. You can alternate on and off, right? As long as you have a system that you stay consistent to, that's fine. Okay. And finally, we're just going to break down which individual parts are. So number 2, you pick every 10th person. Every 10th is systematic sampling. From boarding list, you choose 5 people flying first class and then 25 others. So you're doing first class versus other. That's called stratifying, right? You're based off of one trait, the trait that they're flying first class or the trait that they're not flying first class. That's stratified sampling. And finally, randomly generate 30 seat numbers in survey. So you're randomly selecting 30 seat numbers, right? You're randomly doing something. That's called a simple random sampling. Then a cluster sampling. You randomly select a seat position, right window, right center, or right aisle, etc., and you survey. So based off of their location, that's the cluster that they fit with. It's not necessarily they all have a trait. Maybe the trait, right? That you're curious about, it's just easier just to do people at the aisle, and that's fine. I want you guys to understand SRS is pretty much used, like you use SRS in stratified and in cluster. You don't really use SRS a lot in systematic, right? Like once you stratify your people, between those people, you can use SRS on, and then that'll give you data. Okay. Like I said, we're gonna probably have a Zoom meeting on Wednesday for those that have questions. Your next project is going to be really heavy on chapter 9 and 10. It's not going to be as hard as the other one. There's no real quote unquote math in terms of like computing numbers. It's more logic and just understanding vocabulary. So let's be ready for that. Okay. Like always, if you have questions, shoot me an email. All right. See you guys.